Hello, in this podcast on petroleum, our learning targets are to understand global energy trends for both petroleum and for all energy sources, to understand the effects that petroleum production has on society, security, and on ecosystems, to list the advantages and disadvantages to petroleum use. This is the first podcast for conventional energy. Conventional energy basically is non-renewable energy. It includes the fossil fuels and includes nuclear energy. Now, before we can discuss petroleum, we have to go into some basics on energy. One thing you need to be prepared for is that the AP exam always has a math question, and frequently the math question is on energy, both conventional energy and also renewable energy, frequently together. So don't be surprised if the free response question you get on your test includes some math. With Energy Basic, you need to be aware that energy is the ability to do work, or ability to actually do things. In the universe, there are things and being able to do things. Like, for example, here's the microphone, and the microphone is the thing it's mad. My raising it up took energy in terms of actually moving it, being able to move it. That took energy. Now, energy comes in many different forms. Some of those forms are the energy of heat. There's energy that are in the chemical bonds that keep atoms together, forming different compounds, like one hydrogen atom and two oxygen atoms are held together making water, or sugar atoms contain several different atoms of sugar, hydrogen, and oxygen held together by different bonds. When you break those bonds, that produces energy, and that energy is basically what you use to run your body. There's energy of motion, which is kinetic energy, and also energy of position, which is potential energy. Like if you lift something up, that will put it in energy of position. When you let it go, that potential energy gets converted or changed into kinetic energy, energy of motion. There is electrical energy, and there is also nuclear energy, which is the energy that is holding the protons and the neutrons together within the nucleus of the atom. The first law of thermodynamics is energy can neither be created nor destroyed, but can change its form. Get rid of that second "be created" in there, a little typo in there. In other words, when you lift something up, that energy is converted from the chemical bonds that are in the sugar into energy of motion in moving something up, and like when I moved the microphone up, into the energy of position or potential energy. So everything there was converted, but there was absolutely no new energy. Now, whenever energy is converted, the quality of that energy decreases. That means that its ability to do work decreases, that energy is less efficient. High quality energy is energy that is organized or concentrated and can do useful work. Examples of that would be sunlight, coal, electricity, or gasoline. Low quality energy is energy that is disorganized or it's dispersed and has little ability to do work. Heat is a good example of that. For example, right now there is a lot of heat energy in the ocean, far more heat energy than you would find in all the fossil fuels that are buried in the earth. But this energy is very dispersed, and it is not something that is very easy to use. It is very low quality energy, so it's not something that we could very easily use to do things like run your car. Here's the basic way of how electricity is made. Electrical energy are electrons moving through a wire. The way you get electrons moving through a wire is a magnet is rotating, and that makes a magnetic field, and that moving magnetic field moving through a coil of wire makes the electrons move. And that's the way a generator works. And I can't go too much into this. This is more in the lines of what you would learn in a physics class. So all generators have to do something in order to be able to turn that magnet in that coil of wire to make the electricity turn. And the thing that turns that is called a turbine. That turbine can be turned directly by water flowing over it in hydroelectric power. And another way that you end up turning the turbines would be in a windmill, where the wind is directly turning the turbines. Usually it's what you have pictured over here, where something is producing steam and the flowing steam turns the turbines. So there has to be some fuel that boils water making steam. And that fuel frequently would be something like fossil fuels, which are burned. It could be something that is renewable, like ethanol. This is where the supplies for energy come from globally. And you'll see here that most of the energy comes from conventional energy. And conventional energy is non-renewable, so when it's used up, it is gone. There's coal. Coal is fossil fuels. Oil is fossil fuels. Natural gas is fossil fuels. Nuclear is not renewable because with nuclear we only have a limited supply of uranium in the ground, just like we only have a limited supply of coal, oil, and natural gas in the ground. The other 7.5% are the renewable energy sources. And you see as time goes on, you see the total just keeps increasing and increasing. The amount of oil keeps increasing. For natural gas and coal and oil, it's not increasing at the same rate that it used to earlier on. And where it's coming from is actually a little bit different than now than it was before. Like back 1985 or so, I think it was, most of the oil is coming from new discoveries. And now a lot of the new oil comes from new technology, reopening up old fields or making fields that we knew about, which we weren't able to get at, like, for example, deep in the ocean being made available. Now, how should we measure the energy from fuel? It's sort of like, let's say you have your own business. Yes, you can look at the amount of money that you take in. Say you sell something for $10. You didn't make $10 because there were costs that went into that. What did you buy the item for? What are the taxes that were taken out? What about the transportation that went to it? What about the amount that you had to pay your workers? All those things came out of what you sold it for. So you have to look at the net energy and not the gross energy. The net energy is the energy that's actually in the fuel minus how much energy it takes to find the fuel, how much energy is needed to extract the fuel and processing it too. Then you have to be able to get that energy to the consumers. That could be through a pipeline, it could be through trucks, it could be through tankers. And of course, there's also energy that is literally wasted due to the second law of thermodynamics. And then one energy that is rarely counted in the fuel, and that's one thing that makes fossil fuels so cheap, is the cost to the environment. We don't have calculated into the cost of global warming, like the cost of our changing our society to adapt our society to a warmer climate, of possibly moving populations away from lands that are going to be flooded by the rising ocean, or to species that are going to be going extinct because of the change in the climate. All those things are not being included. Putting aside climate change, also not included in there would be the cost due to pollution. You don't have the cost in there to what happens when there's an oil spill, what happens due to the pollution that comes from acid precipitation. All those things are not included in the price of the gas pump or in your heating bill or your electric bill. Those are not included in your costs. Now, this diagram here shows how fossil fuels are formed. All energy basically comes from two possible sources. One source, which we're going to see in another vodcast, comes from the energy that's bound in the nucleus of the atom. That's nuclear energy. The other is sunlight. What fossil fuels do is that they store the energy of sunlight in chemical energy stored from hundreds of millions of years ago. It was only swamps where photosynthesis succeeded decomposition, with all of these plants and mosses ended up being buried and not being broken down. And over time, heat and pressure, it turned into these fossil fuels. The stuff that was solid is coal, the stuff that was liquid is oil, and the stuff that was gaseous is natural gas. And then we take that stuff out of the ground, and then we get that energy from it. We use that energy, and well, actually some of that energy, the rest of it goes out as heat, and that heat then goes out into outer space eventually. But one thing that remains is the matter. Like we had all that carbon dioxide was from hundreds of millions of years ago, went underground, and now we're putting all that carbon dioxide into the atmosphere. Just recently, the levels of carbon dioxide went up to 400 parts per million, which is higher than it's ever been in all recorded history and all recorded prehistory that we've seen in the glaciers. Now, specifically, we're getting into petroleum, which is also called crude oil or conventional oil or light oil. We'll get into heavy oil towards the end of the podcast. and it is pumped from wells and then transported to a refinery. Now, since it's from wells and is not mined out, that means that there's relatively little disruption to the land compared to mining it out, which is what you get from coal. In a refinery, I have pictured in a diagram here what happens. What they do is they heat it up in a tower, turn the crude oil into a gas, and as the gas rises, it cools. As it cools, each item that's made up in that mixture of the gas, of the crude oil, will come out of the gas and turn into a liquid. Each part will come out at a different temperature. That way they're able to come out with pure things at different levels in the tower. For example, you see here the first thing that comes out, which is the hottest thing, is fuel oil, which is fuel for ships, factories, and central heating. Actually, before that, you've got sort of like this solid residue, which is bitumen, which is stuff for roads and roofing. And then above the fuel oil, we've got lubricating oil. And then above that, you've got the diesel oil. And you keep going up, you end up with smaller and smaller carbon chains. Gasoline at 120 degrees Celsius, and at 7 degrees Celsius, you've got naphtha oil. And then at 20 degrees Celsius, there's liquid petroleum gas. From all of these different mixtures, they're able to make all these different plastics, all these different man-made compounds that we make, PVCs. Oil sources are not evenly distributed worldwide. If you look over here, see the Middle East has 31% of the oil, North America is 15%, and most of that is actually in Canada, and as we'll see, most of that is actually heavy oil and not light oil. And a lot of these countries made an organization called OPEC, which is the Organization of Petroleum Exporting Countries. They control 60% of the oil reserves. They produce 43% of the world's oil, and they make $1.3 million per minute. One of the countries in OPEC is Saudi Arabia, and they control 25% of the oil reserves. 15% of the oil is in Canada. Those are the oil sands. That 25% and 15% is not the same that you see in production. Those have to do with reserves and not production. That's how much they have in the ground, not how much they're producing. The oil sands in Canada, that's heavy oil, and we'll get into that later in the podcast. Now, one crucial thing is that 75% of the oil reserves are in the hands of governments. They're not in companies like BP, which used to be called British Petroleum, and Chevron. So governments control prices and production, and that was crucial, particularly in the 70s during the oil embargo. This I hinted at a little bit earlier in the podcast. Oil discoveries are decreasing, and oil consumption is increasing. And actually, if you look at the graph here, while overall oil consumption is increasing, in the US and Europe they're decreasing. It's in Asia and the Pacific where oil consumption is increasing rapidly. And that's mainly because the living standards there are increasing. But what this has done is that since consumption overall is increasing, this has driven up prices on everything. When you go to fill up your car at the pump, you're not paying based on the supply in the United States, you're paying based on the supply worldwide. So that's driven up the prices on industrialized agriculture, which relies heavily on oil, on petroleum products, on transported products, on air travel, on freight, and on gasoline and everything that uses these things. As the prices keep going up, this may eventually cause a migration away from car-dependent suburbs in the United States. The United States uses more oil than it produces. 85% of the United States' energy comes from fossil fuels, and 39% of its energy comes from oil. But 25% of the United States' domestic oil comes from the Gulf Coast, which is prone to hurricanes. 17% comes from Alaska. The U.S. is producing 9% of the world's oil. It only has 2.4% of the world's reserves, and it uses 24% of the world's oil production. So the concept of drill baby drill to wean us off foreign oil is something that cannot work simply because we don't have the oil to do it. Another problem with foreign oil is that a quarter of the world's conventional oil is controlled by countries that sponsor terrorism, and the oil in these countries are controlled by the governments, and these governments sponsor terrorism. Now, the U.S. does have vast oil reserves deep beneath the Gulf of Mexico. These could boost oil reserves by 50%, but remember, we don't have all that much, 50% with 2.4% of the world's oil reserves. The problem with this is it costs billions to bring the oil to market. It'll take many years before this happens. Once we do that, it'll only meet our current U.S. needs for only 5 years, meet our needs less when it finally comes to market because the amount of energy that we use will probably be more. One controversy that frequently comes up is oil and ANWR. ANWR is the Arctic National Wildlife Refuge on Alaska's north coast. And here's a little video to introduce you to that wildlife refuge.
That I paddled north out of Alaska's Brooks Range and onto the Arctic coastal plain, the 65-mile wide, 500-mile long stretch of tundra that buffered those mountains from the Arctic Ocean. Dappled with flowers and braided by rivers, the plain is the ecologic heart of the Arctic National Wildlife Refuge, what U.S. Secretary of the Interior Bruce Babbitt once called the American Serengeti. If it seems a charitable moniker, consider that the local caribou herd claims 130,000 members, that migratory birds from every state in the lower 48 stop here to rest and feed, that countless wolves, polar bear, and musk oxen make it their full-time home. The date of my arrival was June 22nd, one day after the summer solstice. The sun not going down but moving in a circle, bounding along the horizon like a plane looking to land. After making camp, I hiked west until the tent was out of sight, my shadow stretching ever farther, the temperature dropping slightly, a breeze picking up from the north, bearing a faint though unmistakable scent of the sea. Some time past midnight, I perched myself atop a modest hillock and engaged in no further employment than watching the longest-lasting stretch of orange light I have ever seen. When the sun reached its nadir, which brought the lowest temperature of the day, a silver band of fog developed rapidly over a distant river, the band as sheer and dense as a piece of pipe, and an hour later evaporated. Caribou speed-walked across the plain, their hides scarred and nappy, though otherwise there was little movement. I headed back to camp. Along the way I paused to examine little rainbows at my feet, oil percolating to the boggy surface. Those dreams I used to have, they were less about the Arctic than about the isolation it ensured, the wilderness it represented, the extreme distance, seemingly as far as one could go from Washington, D.C., where I grew up, and still be in the United States. This was an American wilderness, the American wilderness, one with which I was affiliated, for which I felt a patriotic devotion, a fidelity. And this is precisely what some don't have the imagination to comprehend.
So it is a fragile tundra biome, and there are people who want to drill there because there's a lot of oil underneath the ground there. People who are pro-drilling say the U.S. must use all that oil because it will help decrease our dependence on oil and it will help the economy. Those who are anti-drilling say that the amount of oil will not decrease our dependence on oil because there's so little oil compared to the amount that we consume, and that it's not worth the risk of degrading the environment from building the infrastructure to bring the oil to market. And also there's a risk of oil spills, as we've seen in an earlier vodcast, another oil spill in Alaska of the Exxon Valdez. And here we have a summary of the advantages and disadvantages of conventional oil. Advantages are that it gives us an ample supply for the next 50 to 100 years. It has a very low cost. It has a high net energy yield. It's easily transported between countries. It has very low land use since we drill and we don't mine. And the technology is well developed and it has a very efficient distribution system. Disadvantages are since we will be running out within the next 50 to 100 years. We need to find substitutes within the next 50 years. There are large government subsidies for these. The oil companies, even though they're the most profitable companies in business, I'm talking about the U.S. companies, they still receive government subsidies. Environmental costs are not included in the price. The prices are artificially low, and this encourages waste and a search for alternatives. Like when the price was higher back in the late 70s and early 80s, people were purchasing cars that had high gas mileage. But then when the price of cars went back down in the 90s, then people stopped buying cars that had high gas mileages and they were buying SUVs that had very, very poor gas mileage. Also, oil releases carbon dioxide when burned, and that contributes to climate change. And conventional oil can cause water pollution when it's spilled. Now we come to non-conventional oil. First we'll look at oil sands or tar sands. And they are a mixture of clay, sand, water, and bitumen, which is thick, stick, heavy oil. They're found primarily in northeastern Alberta, Canada, which has 3/4 of the world's oil sands resources. The oil sands in Canada and Venezuela actually contain more oil than is found in Saudi Arabia. They are mined and they are not drilled. So that means they can cause extreme environmental degradation. I'll just see pictures here. You won't actually see degradation. So here we're zooming in. And you can already see here the mine. See here how it's green, and here is the mine where it is not. You can see a picture showing the refining in action. Here's a picture that can show you a scale of the mine. Here's a close-up of the mine, showing you the sand. Here's a close-up of the refinery. Here they're refilling the mine pit. This is a cannon that they use to keep the birds off contaminated water. This is called a tank farm. And here you can see oil that's in the pool at the refinery. This is one of the open pit mines that they use. So what you see from those pictures, the pollution problems that you find in mining in general, you find with mining oil from tar sands. The pollution of water, problems of degrading the ecosystem where you're actually mining. Mine tailings are extremely toxic, and this is far more polluting than conventional oil. To get this stuff out of the ground and to refine it means that you end up producing 3 times the carbon dioxide than you would from regular oil. So overall, this causes severe land and water pollution. Another heavy oil is oil shale. And here, instead of being locked up in sand, it's being locked up in a rock. 72% of the world's reserves are in the United States. So the United States, in terms of oil, this kind of oil actually has 4 times the reserves that Saudi Arabia has. And this is enough to supply the U.S. demand for 110 years. But because of the amount of energy and money that is needed to mine it and to convert it to crude oil, this means that this actually has a low net energy yield. And on top of that, it will cause severe land and water pollution. In order to get the oil out of this rock, it requires a huge amount of oil. Most of these oil shales are found in areas like Utah in the arid west. So this rock is found in a desert where you don't find a lot of water. That is one reason why we have not really gotten the oil from this shale. It's not such a good source. Now we come to our concluding questions. Number 1, how is net energy measured? Number 2, for what is petroleum used? Number 3, how can decreasing our dependence on oil increase our national security? Number 4, list one advantage and one disadvantage to using oil. That concludes this podcast, and I'll see you in class tomorrow.